You just change the URI and you're done. And inside the console, you just do set our host with an S on the end of it, 10.0.0/24, set threads 256, run, and it has 256 threads, the entire subnet scanning for that URI, and prints it out. So keep that in mind. If you want to write a quick scanner module, there's a whole bunch of cool stuff already in Metasploit. For example, we've got the exact same version of that, but this version does a put request to the index file with whatever file you have in your local system. So if folks who know what the put request does in HTTP, raise your hand. All right, great. So what this does, it works, you can still do 256 threads at once. You can still give it a whole subnet, and it mass defaces the whole damn subnet every time you run it. So if you're really lazy and they're running front page, that's one way to see if they're running front page. It also supports the delete commands. You can just delete the web root of every host in the local network. So it's an easy way to basically take some new code and scale that code across an entire subnet really easily. And let me get back to the slides real quick. Hopefully I wasn't too far off track. Let's see. Anyway, so you can use Metasploit scanner mixins to write really quick web app scanners and even any application scanner in these Ruby modules, and they're pretty much painless. And you can use the same console, same interface. You can use the GUI if you want, the web interface. They all work the same way. So I was going to do an actual demo, but I think we're going to run out of time if we do that, so keep on going. Client apps. Client applications are really cool because they're always exploitable and no one patches them, and they're the pain in the ass to track what versions are installed where. So you look at a browser and be like, all right, so I got this version of this browser installed. Am I vulnerable? Well, a whole lot comes into play. It doesn't matter what version of the browser you have installed. It matters what version of Flash plugin, what version of Adobe PDF Reader. It matters, do you have Java installed? And if so, do you have a version of the JRE runtime that's exploitable to the recent JNLP overflow? I mean, you can't just look at a single client application and say vulnerable, yes, no. So one thing you need to do is fingerprint what versions are installed, and how you go about doing this is through some of the techniques we'll talk about here. So common probe methods, just mail links to the targets. I mean, don't be afraid to contact the users at an organization. They get all kinds of spam every day in their mailbox. One more spam they don't really understand isn't going to make them that mad. There isn't that much business impact to getting a gibberish email. So keep that in mind when you're doing a pen test. Don't be afraid to contact the users. In the kind of security world, you see folks tend to be broken into two categories. The guys who are really good at social engineering but can't hack their way out of wet paper bag, and the guys who are really good at hacking out of wet paper bags but can't really talk to customers. And the bridge is getting crossed. People are getting better, and I'm meeting more folks who are kind of in the middle there. But you still have kind of that geek stigma of, I don't really want to talk to people. I don't want to actually deal with this person. And so try to get over that when you're doing pen tests, because that's where the easy bugs are, the people.
People are the bugs.
And yeah.
Squash them. Yeah, so, look at things like review exposed weblogs. A lot of times people will actually leave these up so that you can access them from web servers or other means. Send these MDMs to specific victims. This is where, have you ever got one of those emails that said, do you want to reply to let them know you received this email? Basically send them that, because that's a way to see what's going on there. Abuse email addresses like all@target.com, everyone@target.com. These will get you large numbers of people, and they'll be noisy, but you're going to get the information that you want out of them.
I mean, I've worked at 3 security companies, and every one of them has had an everyone or everyone or all email address that you can reach from outside. So it doesn't matter whether half the people on the list, half the people on that distribution list are security people, the other half aren't, and you can still own them via really easy techniques. So, they receive spam to those email addresses. Make your email look like spam. I mean, you don't have to let them know it's you doing it.
Yeah, this is really great on large networks that have 10,000 or more nodes, because you're going to have subsets of the network that don't know any better, and they're going to respond to these. And so you're going to get, all you need is one foothold. Once you have a foothold, you can take over the rest of the network.
All right, the next section is about process discovery, and a lot of folks will go ahead and talk about, this vulnerability or this network layout or this structure or this configuration. What this is about is what your target actually does. It doesn't matter how they do it, what applications they use to do it. What you're trying to figure out is, what do they actually do? Do they do backups in the middle of the night? Do they transfer files from this web server to this web server? How often do they update their website? How often do they go into this directory and do these things? A lot of times you can actually find race conditions where every time, let's say 3 a.m. every night, they go through and delete the whole web directory and upload the files back in. But let's say the order they upload the files in, they don't include the .htaccess file first. So if you've got this tiny little window, you can bypass HT authentication. And we've seen that before, and there's different ways to actually detect that. So just because your pen test says, okay, we've got 2 days to do this, doesn't mean you can't run a 2-day long, profiling attack against their servers. So one easy way to do that, which is becoming less prevalent but still lots of fun, is IPID. So a lot of IP stacks, anytime they send a packet out, they'll increment the IPID in their internal counter. And anytime they send a packet to somebody else, that IPID is then sent out with that. So it's just kind of a counter of how many packets that host has sent out, since it basically booted, depending on what the initialization is for it. You can also look at things like the last modified headers. So Apache will send this by default, but they won't send it by default for active content. So if you're trying to figure out when the web root of a directory was uploaded, don't look at just the .html files. Just do header requests against the image files, and you'll see last modified tags on that. Those last modified tags are usually the time the page was uploaded. If you see a whole lot of those matching the exact same time window, and you see that over a couple of days changing, the day's changing but the time's not changing, congratulations, you just found a cron job. So now what you want to do is build a web scanner that runs, right between that window every night and see if it gets any different results. Is the web root there? Is there a directory listing because they didn't upload indexed HTML yet? Is there a swap file there? Is there a temporary backup like the ones that rsync will make? I mean, look for that type of data. Finally, there's things like FTP servers where they actually expose the statistics of how many times each command was run. And by profiling that over a couple of days, you can determine when the admin actually uploads files, when automated backups are performed, things like that. And here's basically what we just said. Look for patterns of activity. So when you're looking at the IP ID of a server over a period of time, look at how it changes during the day. So during the day, between like 9 and 5, when all the worker bees are using it, you'll see a pretty high level of activity for the most part, especially for web servers, mail servers, things like that. However, in the middle of the night, especially around 8 p.m., all the traffic from US customers drops off. And if you're in Europe, this may be different. If you're in Asia, this may be different. But apply that to your own local time zone. What you'll see is a much lower amount of traffic between, let's say, 8 p.m. and 6 a.m. However, a lot of times when you do this type of test, you'll see a huge spike right around midnight, which everyone's doing backup jobs. So this gives you an idea of when they back up their server. And this can actually allow you to find out how they're doing backups with a little bit more probes. We'll talk about that a little bit more in the next section. For example, FTP stats are also a great way to do that. We mentioned that before. But every Microsoft FTP server out there that allows anonymous login, you can query that stat counter for each one of the commands. You just do type site stats, gives you a huge dump. And even Microsoft's own FTP server isn't invulnerable to that. And we'll give an example of kind of how many times people have logged in, things like that, using that command. And finally, we mentioned this before, but when you're doing profiling via last modified headers, make sure you check the timestamp of the images, not just the static content, because PHP won't return a last modified header. So are there any existing tools for this? I haven't found any yet. Does anyone know of one? All right, well, I'm lazy. I just use hping, stick into a text file, and then grep it out with Perl or Ruby. And I'll show a graph in a couple slides up here, and that graph will actually is based on hping, a little bit of Ruby code, and I'll upload that as part of the materials on metasploit.com later tonight. You can use Netcat for site stats or any FTP client. It's not rocket science. So here's an example of Microsoft.com. And this is actually just one node of their FTP server cluster. And the neat things to keep in mind here are the commands in yellow, which are actually privileged commands. There may be a couple more I didn't highlight, but this gives you an idea of when they actually upload files to this FTP server. If you look over here on the right-hand side, you'll see the store command. And the store command is run 3,000 times since the server was booted, which, as we can tell from the banner, is 47 days. So within 47 days, they've done about 3,000 uploads. In the same time, they've removed 41 directories, they've created 870 new directories, and they've deleted 1,910 files. What this doesn't tell you is whether the command is successful. So you can actually skew these numbers by logging in and just doing a whole bunch of delete commands that the server ignores, but the counter will still get bumped up. One stat that I thought was really interesting was the user command. So in the last 47 days, there's been, 2 billion users logging into this server. And this is just one node of their cluster. So if you ever want to get a size for who actually still uses FTP, 2 billion people in 47 days. Or at least 2 billion connections. So let's see. I think we're doing good on time, so I'm not going to rush this stuff. Yep, we still have.
You would like to do that one demo that you skipped.
Okay. Yeah, we've got a couple demos we'll go back into. We've got one more slide here, then we'll do a little bit of demos, and then I think our break is going to come up. So here's the website hacker.com, and I was like, well, what's a good website to monitor for this demo? And hacker.com looked like it'd be a good one. So what we did basically is just ran hping last night, sending a SYN packet to a port that there's nothing listing on. So the server kept coming back with the reset ACK. And I started this around 10 p.m. last night, killed it about 8 a.m. this morning when I woke up, got some breakfast, just Control-C'd it, and look at the text file. And I ran this through a little Perl script that dumps out just a little, data, basically, the delta between each IP ID, taking into account the 16-bit wrap, because it goes to 65535 and then back down to 0. And just looking at the delta of how many packets are sent per second, removing my own packet from that across this window of time. So at the very beginning, you can see down at the bottom, there's not a whole lot here. It's pretty light traffic. It gets a little bit spiky, but that's folks just downloading big files. But right around midnight, we see this huge spike in traffic, and that must be their automated backup. So there's an automated backup being running at the site right around midnight. It could be someone's shelling in and doing rsync. It could be their W getting something from another site. But we can see there's a big spike of activity at midnight, and then it gets really, really quiet all the way to about 6 a.m. And you can see this nice lull right here. And then right as the USA people wake up again, it starts to ramp back up. So this isn't a great graph. I did this whole thing in about 5 minutes with the Gruff library in Ruby. But it gives you an idea of how just running hping for 10 hours can actually give you really good information about a site. And this example, we know they do backups. We know they do something really big at midnight. We know when their site's most active. So if we're doing a pen test where we're going to take it down, we know when it's going to affect the least amount of users. So all this kind of information you can infer just by looking at how much traffic one host sends. Another good example of that is a VPN server, just pinging their VPN server on 1723 of using PPTP. And check that for a while. And when you see that server going crazy with traffic, you know people are logging into it. So just similar techniques like that. These aren't groundbreaking, these aren't shiny or new or anything like that, but they're stuff that's really useful for pen testing and stuff that we wanted to share.
Yeah, it's sort of a different way of thinking about your target. Like let's say that they do a load every night of their payroll information on a certain server. Well, maybe you want to go after the payroll information. So doing these kind of techniques will get you an insight into the behavior of the network. How is it architected? How do the sysadmins work? When do big jobs happen? What machines are under heavy loads at what time? And you never know when this information is going to be useful to you breaking into a network.
Let's see. So we're great on time. We actually went a lot faster with this than we thought. But we have lots of stuff to demo, so won't be bored, hopefully. So also in the scanner directory, we've got all sorts of things like a vhost brute forcer. Under the SMB directory, we actually have a scanner that'll go through and find the version number of every SMB server in the local network. Anyone here running Mac OS X? Anyone here want to? Okay, a couple folks admit to running Mac OS X. Did you apply that update last night? All right. So finally, after 2.5 months, Apple decided to patch Samba, and which is really annoying because we had this really good exploit for Samba. We just had it in Metasploit. So we're going a little bit more about that in the second half. But if you want to, let's say you're on the wireless network here, you've got a copy of Metasploit 3 installed, and you want to check out this auxiliary scanner stuff, and you want to figure out which people running Mac OS X haven't patched yet. One way to do that is on the MSF command console, do use space auxiliary slash scanner slash SMB slash version. And then just do set our host to be the local subnet. Then you just type run. And everybody running Windows or Samba on Linux, BSD, Mac, etc. will come back and tell you what operating system they're running, things like that. The neat thing about this module is it actually goes a little bit further than just getting the remote OS. It'll actually figure out what service packet it is a lot of times. And these aren't that easy to read on the screen up here, but basically, oh, yep, sorry, syntax. I forgot the red is not readable. There we go. All right. So we look at this smb.client.purnative.os string, which is what the server sends back to us as we do a session setup. And inside this, we can see NT40, 50, 51, 2003, just basic common stuff. Windows 2003 server is actually nice enough to tell us exactly what service packet's running. So Microsoft's getting better at telling us these things. We don't have to guess anymore. No more guessing what target to use for your exploit. It's like, yes, it's 2. Give me that. Thank you. Drive through. We see that continue down here. Windows Vista, exact same thing. They give you the full build number, the version number, whatnot. I mean, they're getting much better at being friendly to us hackers. So down here at the bottom, you see we look for Samba, and in the case